scientific notation is a way to make big number or small number more manageable. That is the first task that you will have to do in today's lab. So in astronomy, we usually use very, very big number. For example, when we define the distances between Earth and the Sun, it is a million and million of kilometers between them. When we define distances between us and stars or galaxies, when we talk about the age of the universe, we talk about billion of years. When you write all those numbers, they include many zero. So that would be an example of distances, for example, to nearby stars. In kilometer. So in scientific notation, we just can get rid of all the zero and write them in a much more practical way, because once we want to do math with those numbers, it's become very confusing very fast. I mean, it's very easy to miss one of those zero or add one when you input the number in the calculator. While using the scientific notation make this much easier and less confusing. So let me give you an example. So let's start by the beginning of the scientific notation. For example, if you try to write 100, let's start small. This is the number 100. In scientific notation, it is written 10 to the power of 2. 2 because when you look at 100, the decimal should be placed there. Usually those numbers do not show the decimal, but you know that when you talk about just 100, the decimal is placed in here. Now, 10 to the power of 2, it means that there is 2 zeros after the 1. Your decimal is placed 2 zeros after the 1. So when you have your 100, you count the number of spots separating the first number, the 1, from the decimal. Yes, so you will count from the decimal 1, 2. There is 2 zeros after the 1. This is 10 to the power of 2. So how do we write 1 in decimal number? Well, how many zero do you see after the decimal? Well, there is 0, 0. So 10 to the power of 0 is equal to 1. 10, there is 1 0 before the decimal, so this is 10 to the power of 1. And so on and so on. 1,000, for example, would be 10 to the power of 3, because from the decimal you have 1, 2, 3 0 after the 1 in here. So let's take a concrete example, one of those big numbers that we use in astronomy. So let's use 350 million. So in this number, your decimal would be right there. Now when you're going to write this in the scientific notation, you first need to decide where you are going to place the decimal for the scientific notation. Now the classical way to do that is to keep only one digit before the decimal. And you usually take the first digit that is not 0, the first digit that the number is starting with. So your scientific notation will become 3.5. And then we're going to deal with all the zero in the scientific notation. So 3.5 by 10 multiply by 10 to the power of the exponent. You get it by counting how far the 3 is from the decimal. So you're counting 1, 2, 3, 4, 5, 6, 7, 8. There is 8 number after the 3. Most of those are zeros. So 3.5, 10 to the power of 8 is equal to 350 million. Let's do the contrary example. You will see some of those in your lab. So what if I give you 2.75 by 10 to the power of 3? So you know from the exponent 3 that your number without scientific notation has 3 digits after the decimal. So like 1, 2, 3. So you'll need to add 1 0. So 2.75 multiplied by 10 to the power of 3 is 2,750. So that's how you work the big number. Now scientific notation can also be used for the small number. So when you talk about big number, the decimal is moved to the left. But if I take a very, very small number, like let's say 0.1, then your decimal is moved to the right. So you're counting how many 0 you have before your decimal. For example, 0.1 is 10 to the power to minus 1. There is 1 0. There is 1 0 before the decimal. On the same example, 0.02 would be, well, let's say 0.01 would be 10 to the power of 1, 2 of minus 2. There is 2 0 before the 1. If I take 0.02, that would be 2 multiplied by 10 to the power of minus 2. So you will have a few of those examples in the lab as well. For example, if we take the 0.03, you're going to count, so to write in scientific notation, you always need to have 1 digit before your exponent. So you take the number that is not 0, we'll take 3. You will place your decimal after the 3 and count by how much you're moving the decimal. So in here you'll be 1, 2, 3. So that is 3 multiplied by 10 to the power of minus 3. This is your equivalent in scientific notation. So for the big number, decimal move to the left. For the small number, decimal move to the right when you go from the non-scientific notation to the scientific notation. So now there is the interest to use this is also to do some math with it. So let me give you an example on how to do some equation with the scientific notation. Okay, so in here we're mostly interested in division, because when you divide a big number by a smaller number, you obtain the ratio. This ratio is how much the big number is bigger compared to the small number. By how much is it larger? And you have a few exercises about that at the bottom of the first page of the lab too. So let's start with a multiplication. I will do the case when we multiply and the case when we divide two scientific number. So let's say that you want to multiply 10 to the power 3 by 10 to the power of 10, multiply by 2 by 10 to the power of 3. So in this one, you will first deal with the digit themselves. You multiply 3 by 2. And then you will deal with the power of 10 separately. And when you multiply scientific notation, what you will do is that you will add the exponent. So you will obtain multiply by 10 to the power of 10, multiply, so 10 plus 3. This will give you your new power of 10. So 3 by 2, this is 6, multiply by 10 to the power of 13. This is your result when you multiply those two scientific notation. So when you multiply exponent, you add them to find out the new power. Now the case that interests us most is what happens when you divide exponents. When you divide exponent, well, you will subtract them. Let me show you this. So we are mostly interested by the division because we want to know by how much a number is bigger compared to another one. So if we have, let's say 8 by 10 to the power of 12 divided by 2 by 10 to the power of 5. So here, same thing, you will deal with the digit first, so 8 divided by 2, and then you'll take care of the power of 10 separately. And in here, because it's a division, you would subtract the number. So it will be 10 to the power of 12, the top, minus the bottom. So this will give you 8 divided by 2, that will give you 4, multiply by 10 to the power of 7. So with this, we know that 2 by 10 to the power of 5 is 4 by 10 to the power of 7 times smaller than the number you have on the top. So you will have a few examples of that at the bottom of the first page of the lab. For example, when you comparing the mass of a pencil and the mass of a backpack, so the pencil is 1.5 by 10 to the power of 1, and the backpack is 1.6 by 10 to the power of 3. So you will see those digits in front of the scientific notation are very similar. So we consider them almost the same. 1.5 is very equivalent to 1.6. So to know by how much the backpack is heavier than the pencil, we're just going to compare those two power of 10. And what you want to do here is take the biggest one, so 10 to the power of 3, a reminder, this is 1000 divided by 10 to the power of 1. 10 of 3 minus 1 is 10 to the power of 2, which is equal to 100. Your backpack is 100 times heavier than the pencil. So applying those principles, so first converting regular big or small number into scientific notation, do that in the first part of the lab, and then work on how to do the math, the division using scientific notation at the bottom of the first page.